Batteries power everything, from your smartphone to your electric car. But what if I told you that the battery you're using today might be completely outdated in just a few years? In 2025, two next-gen technologies are making waves: silicon carbon and graphene batteries. But which one is more promising? Which one will truly change the game? Let's dive into silicon carbon batteries first. These are essentially upgraded versions of the lithium-ion batteries we already know. The key difference? They replace traditional graphite anodes with a combination of silicon and carbon. Silicon can store up to 10 times more lithium than graphite, which means much higher energy density. Imagine phones that last for days, electric vehicles that charge in minutes, and lighter battery packs. Sounds great, right? But there's a catch. Silicon expands during charging, which can lead to swelling and damage over time. Engineers are tackling this challenge with carbon blends and advanced binders that stabilize the structure. By 2025, silicon carbon batteries are not just lab experiments, they're entering commercial devices and electric vehicles in real ways. Now let's shift our focus to graphene batteries. Graphene is a single layer of carbon atoms arranged in a honeycomb pattern. It's incredibly strong, flexible, and conducts electricity better than any known material. When used in batteries, especially supercapacitors, graphene can offer incredibly fast charging, improved thermal management, and longer cycle life. Some prototypes can charge from 0 to full in under 2 minutes. It sounds futuristic, but it's already being tested in smartphones and wearables, with major automakers investing heavily in this technology. However, the mass production of graphene at scale and an affordable cost remains a significant challenge. Visually, think of it this way. Silicon carbon batteries are like upgrading your engine to be more efficient under the same hood, squeezing more range out of familiar lithium-ion chemistry. Graphene, on the other hand, is like switching from a gas engine to electric. It's a whole new platform, and we're still figuring out how to build the infrastructure for it. Both technologies have their pros and cons, pushing the limits of what batteries can achieve. Here's something exciting. Some companies are experimenting with hybrid batteries that combine silicon, carbon, and graphene layers for maximum benefit. One such prototype is already undergoing testing in drones and small electric vehicles. If you're watching this on repeat, pay attention to the layered battery illustrations and charging animations. They show how energy flows differently through these new materials. Now pause for a moment and think. Which battery tech do you believe will dominate the next 5 years? Silicon carbon or graphene? Or is there another technology we haven't even discussed yet? Here's a quick summary. Silicon carbon batteries enhance lithium storage and extend battery life using silicon-based anodes, while graphene batteries provide ultra-fast charging and better heat management. In 2025, both are racing to power the future of smartphones and electric vehicles. And now, the final reveal. Here's a test unit from a startup that has developed a battery pack combining graphene and silicon carbon materials. It charges to 80% in under 3 minutes, holds a charge for days, and stays cool even under stress. If this hits production soon, it could represent the biggest shift in battery technology we've seen in a decade. So if you had to choose, would you prefer a phone that lasts 4 days or one that charges in 30 seconds? Think about it and share your answer.